Okay, even power trick, it's a very, very cool trick. Let's assume we got this equation, which obviously we don't know how to solve. And the question is, when is this set to 0? Let's imagine this is in the denominator or something. And the answer is, it's never set to 0. Why? Here's the trick. You see that this is an even power, and this is an even power, so every power of x is even. And everything which has an even power is bigger than 0. Then this is bigger than 0, and this is bigger than 0, and this is bigger than 0 because it's positive, which means this is always bigger than 0. So I'm going to show you a few versions of the same thing, but it's called the even powers trick. If everything has an even power, then there's something we can say about this even if we don't know how to solve this. So this is always bigger than 0. It's never set to 0. In this version, although has this version has just one solution. Why? Because this is even power and even power, which means it's always positive or 0. So the only answer that sets this to 0 is when x in fact is 0. You can actually do this by factoring out. It's just another way of looking at it. Now there's another version for this trick, which is the same thing just backwards. Negative x to the power of 14 minus 3x to the power of, let's say, 8 minus 5. Again, all powers are even, which means the x itself is always positive. So minus x, minus x is always negative. And again here, this is always positive because it's an even power. Minus 3, always negative, and this is negative, which means this is always smaller than 0. So what I want you to pay attention is to the powers. If all powers are even, I don't know how to solve this, but I can say that it's always positive or negative depending on the coefficients, and then I can find, for example, domains or intersections and stuff like that.